Eurocode 7 stroke BS EN 1997 1 limit states. Eurocode 7 lists 5 limit states to be considered in design process of cantilever retaining wall. That is equilibrium, geotechnical, structural limit state, uplift limit state, and hydraulic heave limit state. You can see the categories of these limit states. That is, overturning is a form of equilibrium or EQU limit state. Bearing, forward sliding, and ground failure are types of geo limit states, and structural failure is a type of STL or structural limit state. So we start with equilibrium limit state. EQU. The loss of equilibrium of the structure or the supporting ground when considered as a rigid body and where the internal strength of the structure and the ground do not provide resistance. For example, in figure A, the limit state is satisfied. The limit state is satisfied if the sum of the design value of effect of destabilizing actions is less or equal to the sum of the design value of the effect of the stabilizing actions together with any contribution through resistance of the ground around the structure, i.e., E destabilizing should be less or equal to E stabilizing plus T, that is resistance due to the ground. In most cases, contribution to stability of the resistance of the ground around the structure will be minimum. So action or resistance due to ground, that is TD, will be taken as 0. There are these other 3 categories, that is ground failure, forward sliding, and bearing failure, which are considered as geo limit states. So what is geo limit state? Failure, it is failure or excessive deformation of the ground where the soil or the rock, as you can see in figure B, figure C, and figure D, is providing resistance. This limit state is satisfied if the design effect of the action ED is less than or equal to the design resistance RD. So the other type of failure is structural failure. Structural limit state. Structural limit state is failure or excessive deformation of the structure where the strength of the structural material is significant in providing resistance. As with the geo limit, the structure is satisfied if the design effect of the action ED is less than or equal to the design resistance RD, i.e., ED should be less or equal to RD. The other types of limit states are UPL, that is uplift, which is the loss of equilibrium of the structure or the supporting ground by vertical uplift due to water pressure or buoyancy or other action. This limit state is verified by checking that the sum of the design parameter and the variable destabilizing vertical action is less or equal to the sum of the design stabilizing permanent vertical action and any additional resistance to uplift. The other type of limit state is hydraulic, that HYD. Hydraulic heave So hydraulic limit state is the hydraulic heave, internal erosion, and piping in the ground, as might be experienced, for example, at the base of a breast excavation. This limit state is verified by checking that the design total pore water pressure UDST or seepage force SDST at the base of the soil column under investigation is set less than or equal to the total vertical stress at the bottom of the column or the submerged unit weight of the same column, i.e. UDST should be less or equal to the stresses STB. So EQU, that is the equilibrium, the geotechnical, and the structural limit states are the most likely one to be considered for design. So uplift and hydraulic heave are not often considered for design. So these three limit states, that is EQU, GEO, and STR, are the most common and are the most often used for routine design. But uplift or hydraulic might be applied in special cases. When checking the geo and the structural limit state requirement, one of the three design approach is used. Design approach 1, design approach 2, and design approach 3. This choice of the three approach reflect the Euro-wide adoption of the standard and offer designer in different nations as approach most relevant to their needs. So design approach 1 is the most likely method to be adopted in United Kingdom. And so it depends in your country, which country you are. So I will end this video here for now. We can continue the next class in the next video. Thanks for watching. If you like this video, please consider to subscribe.